Hi guys, now we're going to actually cover exercise 3D, gradients and intercepts. We're going to start off with understanding gradients. So as we covered in the last exercise or the last class that we had, we understood that the gradient is m and also the slope. So when we're trying to understand what m is or what the gradient is, it's m. It's also known as m, and it's also known as the slope. So how steep the line of the equation is. Another formula that we covered in the last class is that the gradient is rise over the run. And we're going to actually try and answer this question here, which is how do we find out the gradient? So the first step that we need to do to find out the gradient, we need to look at, I'm going to actually rewrite m is equal to rise over the run. Now if we're able to determine the rise first, then we can also find the run, and then we'll find out what that ratio is, and we can determine the m or the gradient. So we're going to start off with the rise. Now I can go to any spot on the graph, but I choose to pick this point because it's on a perfect coordinate, which is -2, -1. So if I start on that coordinate, I can find out my rise, which is 1, 2, 3, 4, 5, 6. And my run, so I'm going to write in green, I'll write it in red. My rise is, we've gone up 6 times. So I'm going to write +6 here. And now let's try and find out what our run is. Start from where we ended. 1, 2, 3. Now if we're going to the right, it's a +3. So the run that we covered was +3. And so pretty much we can just write 6/3, which is equal to 2. So therefore our gradient m is equal to 2. Now we can also, if I delete this, and I'll delete this, we can also pick a different ratio, a different rise and run. We can also pick, say for example, I can see that there are perfect intersections of coordinates here and here. Also here and here. So I can actually make my rise 1, 2, and to the right 1. So it'll be 2/1, which is equal to 2. I can do 1, 2, 3, 4, the rise 4, and the run 1, 2, which is 4/2, which is also 2. So there's many ways of doing it. I can even start, say for example, from here. So we've got 1, 2, and our run is 1. Or 1, 2, 3, 4, and our run is 1, 2. So there are many ways of determining the gradient, and as we can see that the way you actually try to find the gradient is to first determine your rise from starting from one part of the equation, and then move up, find the rise, and then go to the run, go to the right or left until you hit the line or the graph, and determine your run. And then once you find out that ratio, simplify the ratio as we did here. Okay, 6/3 is equal to 2, so the gradient is equal to 2.